Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is February 24, 2024, and the time is 4:26 a.m. Okay, I will be having a mathematics subject for this session. Okay, we've done lots on electronics for the past day, so for this morning, I will be having a verbal problem on algebra. It's not so complicated. It's just the so-called age problem. So this is a verbal problem. Verbal problem, uh, the verbal equivalent, we will change those one to its equivalent in terms of equations. So we can solve for the unknown. Okay, let's proceed. The subject matter for this morning will be a subject matter on algebra. It's not so complicated. So for those of you who are taking up CAT or SAT exam, I don't think that they will give this one on the board exams because it's an easy one. Okay, let's proceed. I will try to read the problem. Nathaniel is 5 halves as old as Dexter. In 3 years, he will be 4 times as old as Dexter's age 3 years ago. How old are they now? So this problem here falls under the so-called age problem, under verbal problem. The only way to solve this problem is to bring out the equivalent of the verbal terms or verbal explanation in terms of an equation so we could solve for the unknowns. Okay, let's try to bring out the solution. There should be a representation for the unknown. Okay, we are solving for the age of Nathaniel and Dexter. So to coincide with their names, okay, we will just introduce or let the value capital letter N to be Nathaniel's age now, and capital letter D, it will be Dexter's age now. The problem is just asking what are their ages now. With the given condition, the first condition is this one, 5 halves. Okay? The first condition is this one. Nathaniel's age is 5 halves Dexter's age. So actually we could relate that one in terms of an equation, meaning Nathaniel's age is 5 halves times Dexter's age. We call that equation number 1. As simple as that one. The next verbal equivalent is a little bit complicated if we do not know the logic behind in 3 years, or that will be 3 years ago. Okay, you cannot solve the problem. So we try to bring out the equivalent of this verbal equivalent in terms of an equation. The age of Nathaniel in 3 years or after 3 years. So it will be his age plus 3. This is Nathaniel's age in 3 years. It's the present age plus 3. Okay? In 3 years. This refers to Nathaniel. And this should be equal to, he will be 4 times as old as Dexter's age 3 years ago. 3 years ago. Okay? If the age of Dexter is D, 3 years ago, the age of Dexter will be D minus 3. You got it, guys? So if we try to relate this verbal equivalent in terms of condition number 2, N plus 3, the age of Nathaniel in 3 years is 4 times, okay, the age of Dexter 3 years ago. So this negative sign here is ago. And this plus here is actually in 3 years. In 3 years. This is plus 3, right? In 3 years. Meaning to say, is present age plus 3, that will be the age of Nathaniel in 3 years. Okay? D minus 3 is actually the age of Dexter 3 years ago. And the given condition is n plus 3 should be 4 times. The given condition is 4 times the age of Dexter 3 years ago. So we call this equation number 2. So this is an easy one now. We are having two linear equations involving two unknowns. So since n is equal to 5 halves d, to solve for the value of n and d, we will take the value n equal to 5 halves d. We put it on equation number 2. So we replace this one by the value 5 halves d. So after the replacement, the resulting equation now just involves the unknown age of this cell. So 5 halves d plus 3 equal to, I'm following this, 4 times the quantity d minus 3. Okay? There is a 2 at the bottom, right? So we will multiply all the terms here by 2. So the first one multiplied by 2, this cancels. It's 5d. 3 times 2 will be 6. 4d times 2 will be 8d. And negative 12 times 2 will be negative 24. Okay? A 5d, we transpose 8d, 8d to the left. This will now be 5d minus 8d will be the negative 3d. And this should be equal to negative 24. We transpose this to the right. This will now be negative 24, negative 6. That will be negative 30. And if we try to multiply this by negative 1/3, right? A minus, in a minus, this will now be plus d, and this 3 here cancel with this 3. In a minus again, this will be plus, and a 30 over 3 will be 10. So the age of Dexter will be 10 years old, and using equation number 1, the value the age of Nathaniel should be 5 halves times 10, or that will be 25 years old. Okay, that's it, guys. That's the solution of the so-called age problem for this morning. It's just a refresher thing, you know. This will be an additional long video format under my channel, and this falls under algebra. And I place this one on the mixed topics because I got the concentration of algebra topics, right? So for the random topics I'm discussing, I will be placing this one on the mixed topics. Okay, this is Professor David J. De Los Reyes. For those of you who would like to subscribe or watch my YouTube channel, my channel is actually at youtube.com/@Prof. If you want to share it, please click share. Good morning from Los Angeles.